Hey there, this is Math 6, Unit 4, Lesson 7. What fraction of a group? We're talking about dividing things into groups when we can't even make one whole group today. And my notes for this one, I wrote yikes. So hang in there today. So today I will most likely make a mistake here or there as I'm talking it through with you guys. I have my notes ready to go, but even as I read my notes, I kind of second guess myself at times and go, is that the best way to say that? So just stay with me and I'll do my best to make it as easy to understand as possible, but sometimes today's lesson can be a little bit tricky. So here we go. Just stick with me. So we first have some estimation. Estimate the following quantities. What is 1/3 of 7? Right? So think about if I had 7, right? If this was like a whole length of 7, pretend that was 7, and I'm talking about a third of it. So a third would be like so. So something along this lines. So what is this compared to the whole thing of 7? We know it's going to be less than 7, right? Because it's not the whole thing. It's going to be somewhere less than half. Half of 7 is about 3.5, 3.5 there. So it's less than 3, probably more than 2, somewhere between 2 and 3, so maybe it's a good answer. Somewhere between 2 and 3 is something that might be a good idea for what 1/3 would be. Again, it's just estimating. What is 4/5 of 9 2/3? Well, let's say 9 2/3, that's about 10. So let's pretend that's about 10. And 4/5 would be something like maybe about here, right? So it's almost a whole thing. 4/5 is a lot. So almost all the way, if the whole thing is 10, we're less than 10, so we know it would be less than 10. Would it be more than 9? Maybe, but it's definitely a little bit less than 10. So that's probably a good guess, right? So maybe between 9 and 10, something like that as an estimate. And this is 2 4/7, that's about 2.5. Of 10 1/9, that's about 10. So again, 10 here. So if we're thinking about what is 2 4/7 of 10, that one's a little bit trickier. So in this case here, we're talking about 2.5 times 10, because the of means multiply type of thing. So 2.5 times 10. If we do this 10 again, it would be 10 again, and half of a 2 becomes here. So you put a 10 and a 10 and a half a 10, so maybe somewhere like 25 might be a good guess for 2 4/7 of that, right? So because we're doing more, it's going to be a bigger number here, right? So back here, when I had a third of 7, I'm cutting it up into thirds. I had 4/5, I'm almost the whole thing. Here I have not just 10 of them, but I have one group of 10, I have 2 4/7 groups, so I actually go larger, right? So I'm going to increase there. So just some stuff to talk about. Multiplication expressions here. This first one becomes 1, oops, I should write it a little smaller. It's okay, 1/3 times 7. Over here we get 4/5 times 9 2/3, and this is 2 4/7 times 10 1/9 as multiplication problems there. Okay? Alright, let's move on to today's lesson. Here we go. Fractions of ropes. So here's a diagram of 4 ropes showing different lengths. We have A, B, C, and D. If I count things up here, A has a length of 1, 2, 3, 4. B has a length all the way over here of 20. C has a length of 9, and D has a length of 3. Just in terms of what it is there. Not that it'll make a huge difference, but just so you have an idea. Wants us to compare the lengths of ropes B, C, and D to the length of rope A. So A is kind of our starting point here. A is what it's like our 1, so to speak. So then use each measurement to show on the grid to write a multiplication equation, division, and division. So we're going to compare, and then we're going to do a multiplication division equation. So rope B is how many times as long as A? So B is here, and we can see that we have one group of 4. 1, 2, 3, 2 groups of 4. 1, 2, 3, 4. 3 groups, 4 groups, and 5 groups of 4. So we can see that rope B is 5 times as long as rope A. As a multiplication equation, we could say that it is 5 times A, 5 times 4, which equals 20. Division equation, we could say it's 20. We're dividing it into 4 length segments, which equals 5 groups of 4. Something along those lines, right? This is 5 groups of 4, and that's what we have. Okay. For C, C says, how is C compared? Well, C is over here compared to A. Well, if 4 is a whole A, right? So this becomes one full one. Okay, think like we did before. This is going to be a whole one, right? So 1, 2, 3, 4. Then we have another one, 1, 2, 3, 4 to there. So we can say, well, that's 2. So it's at least 2 times as many. And then I have this extra piece right here. And remember from our last lesson, we know that that extra piece is 1. Well, this becomes, let's write this out here. This is 1 times as many. Here's another times as many. And this one is going to be 1 out of, how many are in each segment? 1, 2, 3, 4. So that's a 1/4. So we would say that rope C is 2 1/4 times as long as A. For a multiplication problem, we would go ahead and say that 4, or we could say, well, how are we going to do this? We could do 2 1/4 times 4 equals 9. That's our total length there. Or we could take our 9 and we can divide it into 4 segments, and that's going to equal 2 1/4. Or we could also likewise say that 9 divided by 2 1/4 equals 4. Either one would work out fine for that one there. Okay. Now let's compare with D compared to A, because that's our last one here. So our next page here says let's compare D to A. So let's take a look at D. So D is right here at 3, and we know that the full length segment of A is 4, right? So we know that A goes all the way to 4, and D happens to be, in this case here, 3. Now, that means that D is 3 out of the 4 that it takes to make a whole one. So what we would say, we would say that rope D is 3/4 times as long as rope A. As a multiplication equation, we could say that, in our case here, we could say 3/4 the length of D times the length of A is going to be equal to, in our case here, 3. And as a division equation, we're taking the length of the rope and dividing it by 4, and we end up with 3/4. Or we could also say 3 divided by 3/4 equals 4. That would work as well. So each equation can be used to answer a question about rope C and D. What could each question be? So this is talking about rope C and D. So we know that rope C had a length of 9 and rope D had a length of 3. Okay, so if this is our groups, we could be saying how many groups of 3 are in 9. We could say something like that, or how many times does the length of rope D go into rope C? So that's one thing we could be saying with this first one here. You also could say, and I'm going to write this down because it's going to come up in the homework assignment as well, you could also say how many times as long as rope D is rope C. So how many times as long as rope D, which is 3, is rope C? Okay, this is the how many times as long, how many times as long as rope D is C. So that's your idea there. How many times as long as rope D is rope C? So this all goes to that first part right there. For the next one, we could say how many times as long as rope C is rope D. That's one thing we could say there. How many times as long as rope C is rope D? Or we could say, how many times does the length of rope C go into rope D? Those are two things you could say for that one as well. All right, this type of statement, especially this phrase here, will show up on the homework. So that's why I wanted to jot that down for you, just to have a reference. Okay, let's move into the tricky part for today's lesson. Here we go. One batch of an ice cream recipe uses 9 cups of milk. So 9 cups of milk to make one batch. A chef makes different amounts of ice cream on different days. Here are the amounts of milk she used. 12 cups on Monday, 22.5 on Tuesday, 6 on Thursday, and 7.5 on Friday. How many batches of ice cream did she make on each of the following days? Write a division equation and draw a tape diagram. So we need a division equation and a tape diagram for each question. Okay. So what we're doing for each one is we're thinking about there are 12 cups on Monday, for example. Now for Monday, we're going to be saying how many groups of 9 are in 12. That's going to tell me how many batches she actually made. Okay? Now in this case here, we can already tell that if there are 9 cups in a batch and she used 12, we're going to have something greater than 1, right? It should be larger than 1 because it's more. For this one, we have 22.5 divided by the 9 because we're saying how many 9 cups are in 22.5 cups for the number of batches. So that should be greater than 1 on the first one. This one should also be greater than 1, right? Because we can tell that 9 times 1 is 9, so that's going to fit. 9 times 2 is 18, that's going to fit. 9 times 3, 27, too much. So it's going to be greater than 1, and actually we could say it's greater than 2, somewhere between 2 and 3 if we're estimating. On this one here, if we use 6 cups and it takes 9 to make a whole batch, this is again the number of batches, and it makes 9 to make a whole batch. We didn't even use a whole 9, so it tells us that this batch is going to be less than 1. And then finally here, for 7.5 cups used, we know we need 9 for a batch. We use 7.5. It's almost 1. We should get something close to 1, but that batches should also be less than 1. Okay? So use this kind of as a guide as we're going to kind of work through these here to know that our first 2 Monday, Tuesday should be more than 1. The last one should be less than 1 whole batch. So those are our division equations there, at least with the question marks. Okay? So Monday, we're talking about 12 divided by 9 equals something. That's our Monday one. So we can take the first number, and on this one here, since we're doing the whole numbers here, let's just make this simple. Every box is going to have a value of 1. So we're going to go out 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. With the whole number, it's a little bit easier here. So each one has a value of 1. Oops. Okay, and if you're thinking about last time, our 9 is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9 right there. And we know that's one batch. So one batch is right there at 9. So we're finding out how many batches that they made. Well, they made one whole batch. That's easy enough to see there. Okay, so one whole batch is right here for 9. Now a batch takes 9 squares, right? So that's one batch. Put a 1 here for you. Oh, we got a 1 already. That's okay. 1. And what's left over here is they continue to make more. So they made another batch, and it's not really like a leftover, but you know, that's okay. We can say that it is. It's kind of like a leftover. In this case here, they had 3 cups more that they used. And again, that 3 tells us that it is, in our case, let's use pencil here. This is 3, and our total for a normal group is going to be 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 3 ninths. So 3 ninths can be reduced to 1/3. So that, in that case, it was 1 plus an additional 1/3 for 1 1/3. So how many batches of ice cream do they make? They made 1 1/3 batches of ice cream. That's our one whole batch because those are the 9 cups. Then they use additional 3 cups to make 1/3 of a batch of ice cream. So as a full division problem, we could write down 12 divided by 9 equals 1 1/3. Let's take a look at Tuesday. Tuesday is where it starts to get a little bit shaky, okay? So we know we're going to have 22.5 cups divided by 9. And what we're trying to figure out then is how many groups of 9 are in 22.5. Alright, so that's not quite as nice, is it? So let's make 22. We're going to go out here and we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22.5. Alright, all the way out to there. 22.5. That's my 22.5 right there. Okay, so I can write that down, 22.5 if I wanted to know what that length is going to be. Now I know that it takes 9 to make a batch. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we can draw 9 there. That's one batch. And then we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So we can make 2 batches. And then we're left with 1, 2, 3, 4.5. So we're left here with 4.5. Now that's not the value here. I know that in terms of batches, I have one batch plus another batch plus whatever that's going to be. Now that one there is a little bit trickier for us, okay? We know that it's a leftover. We know that for sure. We know that normally what we've done is we said, well, we take the number here and we count them up, and then we put it over the number in a group. So we would have, in our case, we would say we have 4.5. So we can write 4.5 for now, or 4.5, and our group size is 9. And this may not jump out at you right away, but what they want you to know is that it's a nice number, and so there is a way to figure that half of a half out if you wanted to, but really what we have is we have half of 9 is 4.5, because 4.5 times 2 is 9. So the shortcut way is to recognize the number sense here, and that 4.5 times 2 is 9, so this represents half of a batch. Could you figure it out another way? We certainly could, but let's not go into that. That really just complicates things way too much. So in our case, we would say that because they used 22.5 cups of the, what are they using, milk, they made 2.5 batches there. So as a full division problem, we would say that this is 22.5 divided by 9 equals 2.5. And that works out all right. So that little 4.5 might have been a little tricky. Just kind of think about what that represents in terms of how it relates to the whole number 9. So 4.5 is half of 9. Okay, I'm not going to get into how to figure out that other part there, but it can be done. It's just, it gets too complicated. Okay, so as long as it's a nicer number, let's work with it. Now when we get to the next ones, looking at the batches for Thursday and Friday, we already said that Thursday and Friday, all of our answers should be what? What do we say? They should be less than 1. So our answers are going to be less than 1. These ones are a little bit more complicated to draw out and to think about. Okay, that's all right. Let's play with it though. So for Thursday, we know on Thursday that they use 6 cups of milk. and a batch calls for 9. So we have our, normally we say that's our number we're going to start with, right? We're going to say, all right, let's make 6. 1, 2, 3, 4, 5, 6. So that's my 6 right there that we use. We use 6 cups. But we know that for a batch requires what? A batch requires 9 cups. Okay? So my 6 is here. Let's do this. Let's go ahead and make my batch. We've always been making our batches yellow-green. My batch, though, should go all the way out to here, shouldn't it? That's where the batch should be. The problem is I didn't make a full batch, did I? I only made part of a batch. Now, in terms of what part did I make, I can see that I used 6 cups out of how many? I used 6 cups this here. We did 6 cups out of the 9 that I should have been using. So think back to your pink, right? This is kind of like the leftover. In this case here, all we have is pink because I don't have a full batch. I have 6 out of the 9. And that reduces down to 3 goes in there 2 times and 3 goes in there 3 times to 2/3 of a batch is what he made. And that's the idea for that one. Okay, that's our whole. We only made 2/3 of it. And that one works out pretty well because it's nice whole numbers and we can draw that one like so. When we get to Friday though, Friday's a little bit, I just say uglier, okay? Because we have 7.5 divided by 9 is going to equal something. Now we could do the same thing like we just did, and I can make a bar of 9. Okay, actually let's make our 7.5. First of all, like last time, let's make our 7.5. That's our bar. Like that was a 6. So let's make 7.5. So we're gonna go 1, 2, 3, 4, 5, 6, 7, and we're gonna go out to a half right here. 7.5. That's been our pattern here so far. And we're going to take our 7.5 and we're going to find out how many groups of 9 are inside of there. And we already know that in this case here, that's 8, 9. And so what we can tell is that this is going to be less than 1 because we don't even fill up the whole group, do we? It's definitely going to be less than 1. And again, the tricky part with this becomes what I have is I have 7.5, or if you wanted to write a decimal, you could, but what I have right now is I have 7.5 out of 9. That's what I'm looking at, which doesn't really work as nicely as 6 out of 9 does it, okay? So it's hard to really see what that looks like. There is another way of kind of making this work. Let's think of this way, because when we looked at like when this number had a fraction, we divided it into whatever that was, the divisor. So let's make this into looking at halves. If I want to make everything into halves, I don't want to chop this in half, although I certainly could, because I have a half here. If I chop it in half, another way of looking at it is, well, let's just do it. Let's just cut everything in half, okay? Let's go ahead and chop everything into half so that I end up with 18, okay? So right now I have a group box of 9, and let's make everything into halves. So here's a half, and a half, and a half. Cutting everything into halves. That one already is a half. We know that's a half, and that's a half, and that's a half. So cutting everything into halves. That looks really funny. Oh, I know why it's funny. Let me add these lines so you can see them a little bit better. There we go. That makes more sense. Oops, one more. So now what we can see is that when I look at how many pink I have out of the whole thing, I can count the pink and notice that I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 out of what? Out of 15, 16, 17, 18. I have 15 out of 18. That's a lot easier to deal with than 7.5 out of 9. All I did is I said, let's take our denominator and let's double that and make it 18 so that I doubled everything. Think about this. What is 9 times 2? 9 times 2 is 18. What is 7.5 times 2? 7.5 times 2 is 15. So all we did was we just multiplied everything by 2 over 2, which is 1. So we get 15 out of 18, which again reduces down. 3 goes into here 5 times, and 3 goes into here 6 times. So we end up with 5, 6, just like that. So that's a way of looking at that one there. Again, it's not always easy to see. It takes a little bit of extra work, but it does work out, and it was helpful to do a little estimating ahead of time to know my answer should be less than 1. So for sure, this was 2/3 less than 1, and this was 5/6 less than 1. Notice that 7.5 is a pretty close number to 9, so my answer here is almost 1, isn't it? It's almost a whole batch, which tells me I'm on the right track. Let's look at number 3. Write a division equation and draw a tape diagram for each question, then answer the question. What fraction of 9 is 3? Okay, what we're asking here for what fraction of 9 is 3 is we're saying what fraction of 9, so as a fraction, so as a fraction of 9 is 3. 3 is what's up here. Now that fraction bar is the same as division. So this is the same as what? This is the same as 3 divided by 9. That's all we're saying there. 3 out of 9. So if I have a group that is 9 long, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7, 8, 9. There's my 7, 8, 9. And I know that I'm looking for a group of 9 here. But all I happen to have, because it's smaller, is 3. I have 3. We know in this case here that they have 3 out of the 9 that are needed, which can reduce down into 1/3. Just like that. Okay? Let's look at the next one. What fraction of 5 is a half? So a fraction of 5, so that's our 5 here, fraction of 5 is a half. So what fraction of 5 is a half? Or another way of thinking about this is 1/2 divided by 5. So I'm looking for a group of 5, but notice that everything is going to be in halves. So with that in mind, well, I'll do it the small way. Okay. Let's go ahead and do I'm going to draw my box of 5, just so I have that going on. So 1, 2, 3, 4, 5. So there's my 5, which is my group of, right? I'm looking for a group of 5. But I'm looking for a half. So because I'm looking for halves, I need to go ahead and break all of these up into half segments. Right? So now I have half segments inside of my group of 5, but I'm only going to say half is my original size here. So how many 5s fit inside of that half? Well, we would say not very many. My pink is 1. I have 1 out of the needed 10 that are there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 that are there. So 1/10. And that's all I can do. There's no reducing that one there. So as a problem, we would say that 1/2 divided by 5 equals 1/10. Just like that. And there you go. Okay. So that's it for today's lesson. Okay, so as a summary, it's natural to think about groups when we have more than one group, but we can also have a fraction of a group. That's okay. To find the amount in a fraction of a group, we can multiply the fraction by the amounts in the whole group. If a bag of rice weighs 5 kilograms, 3/4 of a bag would weigh 3/4 times 5 kilograms. And you can see a picture drawn there. Sometimes we need to find what fraction of a group an amount is. Suppose a full bag of flour weighs 6 kilograms. A chef used 3 kilograms of flour. What fraction of a full bag was used? In other words, what fraction of 6 is 3 kilograms? and that's what's down here. This question can be represented by a multiplication and a division equation, as used here, right? What fraction of 6 is 3? This is the what fraction of 6 is 3? Or as a division, 3 divided by 6. So how many groups of 6 are in 3? And that was the idea there. So back to our idea, we said, all right, if this is my whole, this is what I'm looking for, that's my group of 6. How many groups of 6 are inside of 3? Well, I didn't get a lot. In fact, what did I get? I got 1, 2, 3 of them, but actually the whole group size is 6. So I got 3 out of 6, which reduces to a half. And so that's exactly what we end up with here. When we check our work, we can see that you get half of what you need to make a whole. All right. In any situation where we want to know what fraction of one number is of another number, we can write a division equation to help us find the answer. So what fraction of 3 is 2.5 can be expressed as what fraction of 3 is 1/4. Can also be 2 1/4 divided by 3. Okay. Now what does this mean? This is how many groups of 3 are in 2 1/4. The answer to what is 2 1/4 divided by 3 is also the answer to the original question. So it's the same answer each time. The question marks are going to be the same thing. Okay? So it depends on how you want to think about it. And here's an example showing what that is. So there's our 3. That's our 3. You want to see how many? That's our 3 groups, right? That's our 3. And how many 3's are inside of 2 1/4? Well, in this case here, it's going to be less than 1, correct? And what they went ahead and did, because it's looking at fours, is they took the whole and they broke them up into fours and they counted them up. You have 1, 2, 3, 4, 5, 6, 7, 8, 9 out of a total of 10, 11, 12. So that reduces into 3/4, right? And there it is right there. The diagram shows 3 wholes, contains 12 fours, and 2 1/4 contain 9 fours. That's where we got the 9 from. So the answer to the question is 9/12, which is 3/4. We can use diagrams to help us solve other division problems, and there's another example right there. And I think that is it. Let me double check. Yep, and that's it. All right, that's it for today. Good luck with the homework. Take your time, and if you get a little hung up or stuck, that's okay. I did too. All right, see you in a minute. All right, here's our homework for lesson 7. Okay, so first of all, a recipe calls for 1/2 pound of flour in one batch. How many batches can be made with each of the following amounts? Okay, so what we're doing is just saying, okay, I need 1/2 pound for a batch of for a recipe. Here I have 1 pound. So what I'm asking here is really how many of the 1/2 pounds are inside of 1, and that's going to tell me the number of batches I can make. Just like here, I have 3/4, and I want to know how many halves are in 3/4 to tell me the number of batches I'm going to make. And here I have 1/4, so I want to know again how many halves are in 1/4. Okay, so that's kind of the idea we're talking about here. So let me go ahead and draw some little diagrams here. I'm going to draw one here. Okay, I'm going to draw another one right here for the second question. And we'll draw one here for the third one. Alright? And these are all ones. Now, that's 1, but I'm playing with a half. Okay, that's okay. I know that in my example here, I'm dealing with halves. Right? And so, because this is what I'm dividing things by, that's my half that I'm looking for. Each time it's a half, it's a half, it's a half. So in our first one, what I have is I have 1 divided by a half. Well, 1 is a whole thing, isn't it? So 1 is going to be, in our case here, the whole, which is this whole thing. So it goes beyond the half. So how many halves are in here? I actually end up having 2 halves inside of one whole, right? Do you see how that works out? I have a half here and I have a half here. So how many do I have? I have 2 halves. I'll write it down this way. I have 2 halves in 1 pound. And you can see that there. I can draw another half here and help you see it. I have a half there and I have a half there inside of 1. Another way of looking at it is one way of looking at it there. So I have 2 halves inside of 1. Okay, so that's batch is going to be equal to 2. So the next one though is I have how many halves are in 3/4. I'm dealing with fourths here. So let's chop our 1 up into fourths. I have 1, 2, 3, 4. Okay. So I'm saying how many halves are inside of 3/4. Okay, so 3/4 here goes out to here. We can see that it's going to be 1, 2, 3 of the whole thing. So how many halves are in 3/4? Well, in this case here, I have a whole one and a little bit more. Okay. So I'm going to go ahead and think about, in this case here, I have a whole half, so that's one of them, and then I have one more extra piece, but that extra piece, how many is that compared to the half? It's 1 and it takes 2 to make a half, so I have 1 and a half. So I have 1 and a half in 3/4 as my answer there. For the next one, I want to know how many 1/4 are in a half. So here's, or sorry, how many halves are in a 1/4. So there's my half there. Okay, and when I cut the whole thing into fourths, I can see here that I have a 1/4 right there. So this is my half right there. And I have 1 in there, but I need a total of how many? I need 2 to make a whole. So I have 1 out of the needed 2. Up here I have 3 out of the needed 2. And if you looked up here, right, what did I had? I had actually 1, 2, 3, 4 out of the needed 2. So when you reduce all those, that becomes 2. This becomes 1 and a half. And this one just stays a half. Alright, so I hope that makes a little bit of sense there. Each time I do these, I do them a little bit differently because I see it a different way, but hope that helps out a little bit for that one. Now let's look at number 2. It says Whiskers the cat weighs 2 2/3 kilograms. Piglio weighs 4 kilograms. For each question, write a multiplication and a division equation. To decide if the answer is greater or less than 1, then answer the question. Okay, how many times as heavy as Piglio is Whiskers? Remember that one question where I said you're going to see that how many times as heavy is something is something? There it is. So, how many times as heavy is the how many times as heavy as Piglio? Well, Piglio is where? Piglio weighs 4. Is Whiskers. Whiskers is 2 2/3. Or as a division problem, we could write this as 2 2/3 divided by 4 equals something we don't know. Okay? So it's going to give us the same question mark answer here. So we can think about this as being how many groups of 4 are inside of 2? Right? How many groups of 4 are in there? Well, if I have $2 and ask you, can I have 4? You don't have enough. So this should be less than 1 as an answer because 4 is not going to quite fit in there, right? So this works out like this. This is like doing a, here's 1, here's 2, here's 3, and here's 4. The first number we've said before is kind of like our blue box, right? Now I know I'm doing it with thirds, so let me go ahead and just chop up into thirds real quick. So 1, 2, 1, 2, 1, 2, 1, 2. And my blue box is 2 2/3. So here's 1, 2, and I get 2 2/3 right here. And what I want to know is how many 4s are fitting inside of that box right there. Well, in this case here, we can see that I'm actually only going to have, how many of these? I end up having 1, 2, 3, 4, 5, 6, 7, 8 of the blues, and I really should have a total, for the whole group, I need 8, 9, 10, 11, 12. So I only have 8 out of the needed 12 is what I end up having. That's what I have there. So I have 8 out of the needed 12, and I can draw these here, just to shade those in so they show up a little bit better for you. So I have 8 out of the needed 12. I'm not sure why I made it pink. Probably needed that. That's okay. And so that can reduce down to 2/3. For the next one, how many times as heavy as Whiskers is 2 2/3 equals Piglio. Or as a division problem, we're doing 4 divided by 2 2/3 equals question mark. Okay, so again, what am I expecting here? How many 2 2/3 are in 2? Well, are in 4, sorry. That's going to be greater than 1 as an answer. The question is how much greater than 1? So let's do this. Let's do 1, 2, 3, and 4. And we're going to chop those whole 4s, because that's my 4, right? Let's chop my 4s into thirds. So 1, 2, 1, 2, 1, 2, 1, 2. And let's see how many 2 2/3 are in there. Okay, so sometimes it's hard when I chop those up, I can't see my holes anymore. So here's my hole numbers. Okay, cool. So let's do 2 2/3. So we have 1, 2, and 2/3. Oh, I used the wrong color. Sorry about that. Okay, that's right. So I know I have at least 1, right? Would you agree there? There's 1. I should have used my yellow and green like last time. So I have 1 there, but then I have this extra. Sorry, I'm going to make my extra green this time. I have 1, 2, 3, 4. So for my extra, I have 4, but I would actually need 1, 2, 3, 4, 5, 6, 7, 8 to make a whole group. So I have 4/8 reduces to a half. So what I have with the green is I have a half. So I have 1 1/2. So that becomes my answer, 1 1/2. Okay, so how many times as heavy as Whiskers? He's 1 1/2 times as heavy. All right, and that is it for number 2. Sorry about the color mix up there. All right, number 3. Andre is walking home from a festival that is 1 5/8 kilometers away. He takes a quick rest after walking 1/3 kilometers. In this situation, which question can be represented by the equation something times 1 5/8 equals 1/3? All right, so let's see. What fraction of the trip has Andre completed? Okay, so what fraction of the trip has he completed? So that's going to be how much of the whole thing has he completed? Okay, and that would be a question mark right there. So I'm sorry, I'm backing up here. I got ahead of myself. Ignore that, erase that, just gone. So what fraction has he completed? This one here, let's look here. This could also be written as 1/3 divided by 1 5/8 equals question mark. I got ahead of myself, right? So if I want to know how much of the whole thing has he done 1/3, that would help me out there. So this one's just fine actually. What fraction of the trip has he completed? Because that's going to tell me that he's done 1/3 of the whole trip. So back to what I had before, that's that fraction of the trip. What fraction of the whole trip has he done? He's done 1/3 of the whole thing. So 1/3 of the whole thing there looks like that. How many more kilometers does he have to take to walk through the festival? That's not going to answer that. And what fraction is left? That's not going to answer that there. If they use 2/3, that would work, right? But that's not what they use there, so I'm not going to do that. So we're going to go with A. A is the best answer. Yes, there's a D choice, but it's also wrong, so we're going to ignore it. All right, number 4. Draw a tape diagram to represent, answer the question, what fraction of 2.5 is 4/5? Or another way of thinking that is this question mark times 2.5 equals 4/5. Or as a fraction problem, 4/5 divided by 2.5 equals what? So we're asking here, how many 2.5s are in 4/5? So already we know that we're going to get kind of a weird answer here, right? We're going to get a small answer, less than 1, because 2.5 is never going to fit in there. So we need something less than 1. Less than 1, less than 1, less than 1. So we have 2.5s. We're dealing with fifths, so we could look at making this into groups of 5. We can make a bar here of 1, and we can make a 2, and we can make a 3 to start with here. Now I'm doing groups. If I did groups of 5, think about this here. That'd be 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Nothing wrong with that. Like, that's good thinking so far, right? If I'm doing groups of 5 because of the denominator, I'm following that regular pattern we've talked about so far. That sort of makes sense so far, right? We're okay with that? But then when I have to do 2.5 to find out where I start from, the 2.5 is going to be right here. So what problem do you already see with that? Well, I had to cut 1 in half, didn't I, to make that 2.5. So it might be best to go ahead and actually cut everything into halves. It might be best, but let's just see. If I want to do 4/5, 4/5, 4/5, and I want to know how many 4/5 are inside of 2.5. Okay, well, to do that here, let's see what would happen. Let's just give it a shot. So this is my 4/5. I want to see how many 4/5 are inside 2.5. If I do my 4/5, what I would have, if I did 4/5 is here, I could leave it there, but then I have this crazy number. It doesn't quite, it's not a nice number. Let me just draw it. So if I said 4/5, it won't fit in the whole thing. So let's just do a 4/5. 1, 2, 3, 4. So I'm kind of talking and thinking. Hope you don't mind that. If I have 4/5 there, I would normally say that what I have is I have 4 out of the number I have here. But what do I have? I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 and a half. That's a weird number, right? 12 and a half. I really don't probably want to mess with 12 and a half. It's just, it doesn't make a lot of sense to me. Okay, you okay with that not making a lot of sense? So if I cut all those in half, again, like this, I'm not changing anything, but what I'm doing is I'm saying, oh, I doubled the number of slices, so I'm multiplying everything by 2, and I end up with 8 pink ones here out of a total of 25. And that might make a little more sense. So the reason why I did that is I don't really want 4 over 12.5. That doesn't make any sense at all to me. Why would you have a decimal mixed with a fraction? That's just goofy. So if we cut everything in half again, if we cut our fifths into halves, end up with tenths here, you end up showing that you have 8 out of the 25. So what we're saying here is that if I'm asking how many 2.5s are in 4/5, this is where 4/5 is at. And we can see we don't even have a full one, right? We only have 8 out of the needed 25 to make a whole one. That's what I have there. So that becomes my answer, and that's the way that works. Okay. All right, how many groups of 3/4 are in 11/4? Okay, so this is 11/4 divided by 3/4. How many groups of 6.5 are in there? So 6.5 divided by 3/4. Okay, so we have 4 11s right there. That's kind of a crazy number. As a mixed number, 4 goes in here 2 times, right? And then we end up with 2 times, and that's 8, 9, 10, 11, 2 3/4. So we have 2 3/4 divided by 3/4. So let's just draw this out here. This becomes 1. This becomes 2. And this becomes 3. We're dealing with fourths here, so let's make it into fourths. Cut it in half and half again, half and half again. I only have 2 3/4, so that's going to be right here. 1, 2 3/4, like so. And we want to know how many 3/4 are in there. So 3/4, we have 1 group of 3/4. We have 2 groups of 3/4. We have 1, 2, 3 groups of 3/4. Alright, so we would say so far we have 1, 2, 3. And over here I have my leftover. And in my leftover category, what do I notice? I have 2 leftover. 1, 2. Out of how many are needed in each group? 1, 2, 3. 2/3. So we have a 2/3 right here. So we end up with 3 2/3. Here's our solution for that one. And our next one, we have 6.5 divided by 3/4. So again, we're going to make 6 little blocks here. So there's 1, 2, 3, 4, 5, and 6. We're going to put them into, I'm going to put them into fourths because we got to break them into fourths. So here we go. We have 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, and then 1, 2, 3. But I'm doing 6.5, so I need to go another one, right? Oops, sorry about that. And we'll go 1, 2, 3. And so because it's 6.5, I'm going to come out here and go 1, 2, 3, 4, 5, 6.5. That's what I'm working with there. And we're going to divide it into 3/4 chunks. So we're going to go 1, 2, 3, 4, 5, 6, or 1, 2, 3, and then 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, and then we have leftover, don't we? Okay, let me fill in my little dots here, my 3s, just so it looks nice. 3s and 3s. Okay, but I have leftover. I have 2 left over there. So what do I know? I know that I have 1, 2, 3, 4, 5, 6, 7, 8 whole groups of 3/4. And then over here I have 1, 2, but it takes 1, 2, 3 to make a group, so I have 2/3. So I have 8 2/3. Alright, and that's a review problem from yesterday. Okay, number 6. Which question can be represented by the equation 4 divided by 2/7 equals what? Okay, so this is how many 2/7 are in 4, or how many groups of 2/7 are in 4, is what that is showing us there. So what is 4 groups of 2/7? This would be, what is 4 groups of 2/7? Nope. How many 2/7? Oh, I should write like this. How many 2/7? They're all fancy. Are in 4. So this one here is actually correct. How many 2/7 are in 4? That's good. What is 2/7 of 4? That's going to be what is 2/7 of 4? So that's not right. And how many 4s are in 2/7? Well, that is this one. 2/7 divided by 4. And that's what that one is. And that's not what we're looking for. So that'd be wrong. Okay, that is it for today. Hope that helps you out a little bit, and we will see you next time.